All right, so today we're going to talk about the rational root theorem. And so what this theorem says is that if we take our constant, our number at the end, which they represent by the letter p, and we take our leading coefficient, the number attached to your variable with the highest exponent, which they denote as q, and we're going to take the factors of those and then write that as a fraction of p over q. When we do that, that's going to give us a list of all possible rational roots. Now, we know that we're going to have 3 roots. We just don't know how many are rational and how many may be either irrational or imaginary. So let's take a look at what this looks like. Let's do factors of p first, meaning what times what gives me 8? Oh, well, we know that 1 times 8 gives me 8. Also, we want to use plus or minus to denote these. So plus or minus, because we can have positive or negative for both of these. What else will give me 8? Well, we know that we have 2, so plus or minus 2 times plus or minus 4 will also give me 8. So 1 times 8, those are factors, and 2 times 4, so those are factors. So all of our factors of 8 are 1, 2, 4, and 8. In the same way, we need factors of q. So factors of q are going to just be plus or minus 1 and plus or minus 2. So the only two numbers that multiply to give me 2 are going to be 1 and 2. Finally, to get our list of all possible rational roots or rational zeros is to put this over a fraction, so p over q. So we're going to take every factor of p and divide it by every factor of q. And so to go in somewhat of an organized order would be most helpful. So we have 1 over 1. So we're going to kind of start here. So 1 over 1. So plus or minus 1 divided by 1. And then 1 over 2, right? Plus or minus 1 over 2. Now I'm not going to do that with every one. But then finally go to the next one. Plus or minus 2 over 1. So plus or minus 2 over 1. Plus or minus 2 over 2. So plus minus 2 over 2. Then plus or minus 4 over 1 and 4 over 2. So plus minus 4 over 1, 4 over 2. And then finally 8 over 1 and then 8 over 2. So plus or minus 8 over 1 and 8 over 2. Now, the first time you do this, you might want to write all of these factors out. But what you're going to notice is that some of these repeat, and you'll have to write those factors that repeat. So let's see where we get some repeats. So 1 divided by 1 is 1. So our actual list is going to be plus or minus 1. So we're good here. 1 divided by 2 is just 1/2. So plus or minus 1/2. So we're good there. Now 2 divided by 1 is just 2. So plus or minus 2. Here's where we're going to start getting some repeats. 2 divided by 2 is 1, and that is already in our list. So we don't have to rewrite that. That's why you don't have to really do this first step. If you can see that ahead of time, then you can skip straight from here to here after you get used to it. Now, plus or minus 4 divided by 1, that is not in our list. So plus or minus 4. But 4 divided by 2 is 2, and that is already on our list, so we don't have to include that. And then plus or minus 8 over 1 is not in our list, so we're going to say plus or minus 8. So this is gone. Now plus or minus 8 over 2 is 4, which is already on our list, so we do not need to include that. So total possible rational roots, meaning if we were to graph this on our calculator and we were to see where it's going to cross the x-axis, it can only cross and be a rational solution at one of these points, a positive 1, a negative 1, positive 1/2, negative 1/2, and so on all the way through.